Kia ora. This video is on solving 3x3 simultaneous equations using the elimination method. So the three equations have three variables which form a plane, and they all tend to intersect at one point, and that's what we're trying to find. We use the elimination method when adding or subtracting the equations would remove a variable. The goal is to eliminate the same variable from two different pairings of the equations. And by pairings, I mean pairing like 1 and 2, 1 and 3, or 2 and 3. And sometimes you may need to multiply the equations to make this work. The example that we're using is from the Walker book on page 15, and these are the three equations here. Now, I noticed that if I multiply equation 1 by 2, when I pair it with equation 2, it will eliminate the x variable. And if I take equation 1 and multiply it by 3, and combine that with equation 3, it will eliminate the x variable. So those pairings will eliminate the x variable for me. So what I'm going to do is I'm going to take equation 1, I'm going to multiply it by 2 to create a new equation, which gives me 2x plus 6y minus 4z, which equals 10. And I am pairing this with equation 2, which is 2x plus 4y plus 3z, which equals 8. So this equation here we're going to label 4, this is equation 2, and when we take equation 4 and subtract equation 2 from it, that will give us our new equation of equation 5. So 2x minus 2x, they cancel. 6 minus 4 is 2y. Negative 4 minus 3 is negative 7z. And 10 minus 8 is 2. So that is our equation 5, which is an important equation. That comes from the pairing of 4 and 2. So okay, so it was 1 multiplied by 2, which created 4, and the pairing of 4 and 2. So we're now going to repeat this again. So we're going to take equation 1 and we're going to multiply it by 3, which gives us 3x plus 9y minus 6z equals 15. And this new equation is equation 6. So then I take equation 3 because I'm pairing equations 1 and 3 here. Copy that one down, so I get 3x plus 5y plus 6z equals 7. This is equation 3. And what I'm going to do is I'm going to take 6 and I'm going to subtract 3 from it. Okay, so the x's cancel out. 9 minus 5y is 4y. Negative 6 minus 6 is minus 12z. 15 minus 7 is 8. And this new equation I'm going to call 7. Okay, it's important. And it is from pairing 1 and 3 when 1 became 6. Okay, so our pairings were 1 and 2, 1 and 3, producing these two equations here. Now, when I look at those two equations, I notice that if I take equation 7 and divide it by 2, that will leave me with 2y, so I can use that to cancel out the y's. Okay, so we've got equation 5. Actually, we'll start with equation 7 and we'll divide it by 2 so that we get our correct y value. So that is 2y minus 6z equals 4. And then I will take equation 5 and just copy that down below. So I get 2y minus 7z equals 2. And what I'm going to do is I'm going to take equation 7 and I am going to subtract equation 5. And this will cancel out the y variables. So 2 minus 2 cancels. Negative 6 minus negative 7 gives us z, just 1, and 4 minus 2 gives us 2, which is our first solution, z equals 2. Now I am going to substitute z equals 2 into equation 5. So that gives 2y minus 7 lots of 2, which equals 2. So therefore 2y equals negative 14, add that to both sides, gives us 16. So y equals 8, which is now our second solution. From that I can substitute z equals 2 and y equals 8 into one of my original equations. I'm just going to choose the first one. So that gives me x plus 3 lots of 8 minus 2 lots of 2, which equals 5. So x plus 24 minus 4 equals 5. Simplify that and x equals negative 15. Okay, so our three solutions. The point of intersection occurs at negative 15, 8, and 2, which can be written as x equals negative 15, y equals 8, and z equals 2. Like we did before, I'm going to double check these using the online solver tool. So when I bring this up, I can enter in my equations. So the first equation was x, so that's a 1. It was plus 3y, and it was minus 2z, and it equaled 5. The second equation was 2x plus 4y plus 3z equaling 8. And the final equation was 3x plus 5y plus 6z, which equals 7. And show me the solution without the steps, because the steps are no use to us. They solve them using different methods. Oh, I put an S instead of that correct one, which should be a 5. click to solve it, and you'll see that it agrees with this, where x equals -15, y equals 8, and z equals 2. Have a go at the exercises that I've put on Google Classroom. I've got a copy of the notes on Google Classroom, so you can look at those as well. Once again, if you've got any questions about any of this, flick me an email or post, put a message on the post. I'm happy to make more videos with more examples if needed. Okay, thanks. Bye.